What China discovered on the dark side of the moon could change the fate of all humanity. A source of unlimited energy, ready-made underground cities, and resources worth trillions of dollars, and all of it is already in the hands of one country. While the rest of the world argues whether we should go to Mars or focus on solving Earth's problems, one nation is quietly and methodically taking control of the most valuable object in our solar system. And it's not some distant planet. It's our very own moon. Right before our eyes, China is becoming the master of the moon's dark side. And that means that in 10 to 15 years, the global balance of power could drastically shift. For a long time after the Apollo and Soviet lunar programs of the 1970s, humanity seemed to lose interest in our planet's satellite. Everyone looked further, to Mars, Jupiter's moons, and exoplanets. The moon seemed studied, boring, a thing of the past. But while everyone was dreaming of distant worlds, China was making entirely different calculations. In the early 2000s, Chinese scientists and engineers sat down and coldly analyzed what is needed for a technological breakthrough. Where can we get resources for energy independence? And how do we surpass our competitors while they're lost in daydreams? The answer was simple and brilliant. The moon, not Mars, which takes at least 9 months to reach. Not asteroids, which are nearly impossible to get to, but our good old moon, just 3 days away by spacecraft. In 2007, China launched the first probe of the Chang'e program, named after the moon goddess from Chinese mythology. But this wasn't about romance. It was cold calculation. Chang'e 1 created detailed maps of the lunar surface and, most importantly, discovered traces of helium-3 in the lunar soil. Helium-3 is an isotope that could become the fuel for future nuclear fusion reactors. Just 1 kilogram of it can produce as much energy as 10,000 tons of coal. There's virtually none of it on Earth. But on the moon, millions of tons, brought there by the solar wind over billions of years. What makes helium-3 so special? Unlike other types of fusion fuel, the reaction with helium-3 does not produce neutron radiation, meaning safer and simpler reactor designs. No radioactive waste, no risk of a meltdown. Just pure energy in incredible quantities. According to Chinese physicists, 40 tons of helium-3 could power the entire United States for a year. And on the moon, even by the most conservative estimates, there are over 1 million tons of it. That's enough to power humanity for thousands of years. While Americans debated shutting down the space shuttle program and Europeans and Russians looked toward distant planets, China was already planning how to become the world's #1 energy superpower. Chang'e 2 in 2010 took even more detailed images and selected landing sites. It photographed the lunar surface with 1-meter resolution, sharp enough to see the footprints of American astronauts and the equipment they left behind. But most importantly, it mapped helium-3 concentrations in various regions. Then in 2013, a historic event occurred, largely unnoticed. Chang'e-3 made the first soft landing on the moon since 1976. For 37 years, no human or machine had touched the lunar surface. Then suddenly, the Chinese rover U-2, Jade Rabbit, rolled across the gray dust. U-2 weighed only 140 kilograms, but was packed with cutting-edge instruments. A panoramic camera, an infrared spectrometer, ground-penetrating radar, an X-ray spectrometer, allowing for unprecedented lunar research. Crucially, it was powered by a radioisotope source, enabling it to survive the freezing lunar night. But that was only the beginning. The real sensation came on January 3, 2019. Chang'e-4 became the first spacecraft in history to make a soft landing on the far side of the moon. The far side of the moon isn't just something we can't see from Earth. It's a completely different world. There are no radio interferences from our planet. Its ancient geology has been untouched for billions of years. It holds the Von Karman crater, part of the massive South Pole Aitken Basin, one of the largest structures in the solar system. This basin is 2,500 kilometers in diameter and 13 kilometers deep. It formed about 4 billion years ago after a collision with an asteroid half the size of Great Britain. The impact was so powerful, it nearly punched through the moon's crust and exposed its mantle. The technical challenge of landing there was immense. There's no direct communication with Earth. The moon blocks all signals. So, a year before the landing, China launched a special relay satellite, Keiqiao Magpie Bridge. It orbits in the L2 Lagrange point behind the moon, providing constant communication. Keiqiao is a true engineering marvel. Weighing 425 kilograms, it's equipped with a 4-meter parabolic antenna and can transmit data at speeds of up to 2 megabits per second. Most importantly, it's perfectly positioned to maintain uninterrupted contact with both Earth and the far side of the moon. No one had ever done this before. And Keiqiao isn't just a relay. It also carries a low-frequency radio telescope that can study the universe in ranges blocked by Earth's atmosphere and human-made signals. In effect, China created the first deep space radio observatory to explore the farthest reaches of the cosmos. When Chang'e 4 landed in the Von Karman crater and deployed the U-2 rover, humanity saw the far side of the moon up close for the first time. And what they found changed everything. The first big discovery was in the composition of the soil. Analysis showed the far side had far more rare elements than expected. Titanium, iron, and rare earth metals were found in much higher concentrations than on the near side. Among the samples later returned by Chang'e 5 was a new mineral, chainsight, which contained traces of helium-3. Chainsight is a crystalline phosphate with helium-3 atoms trapped in its lattice. It formed under billions of years of solar wind exposure on lunar basalt. In the 50 years since Apollo, no one had discovered new minerals on the moon. The Chinese were first to make this astonishing find. But a real bombshell came when U-2 stumbled upon a strange shiny substance in a small crater. Social media exploded with wild theories, alien contact, secret weapons, conspiracies. In reality, it was glass, formed by a recent meteorite impact. But the discovery proved that the moon still holds surprises. This impact glass had a unique composition. A mix of silicon, aluminum, and other elements melted at over 1,700 degrees Celsius. Analysis revealed the impact occurred just a few million years ago. And most importantly, the glass contained mantle material, confirming theories about the moon's inner structure. Then something happened that became a symbol of a new era in space exploration. Along with scientific instruments, Chang'e 4 delivered a small biosphere to the moon, a sealed container with cotton seeds, potatoes, rapeseed, Arabidopsis, yeast, and fruit fly eggs. The biosphere was an aluminum cylinder 18 centimeters tall and 16 centimeters in diameter. Inside, a stable temperature was maintained, along with water and air supply systems, and a video camera to monitor the experiment. The total weight was nearly 3 kilograms. On January 15, 2019, Chinese scientists announced that a cotton seed had sprouted. For the first time in history, a plant from Earth grew on the surface of another celestial body. A tiny green sprout in a lifeless gray desert became a powerful symbol that life could exist even there. The sprout reached nearly 1 centimeter in height and produced 2 cotyledon leaves. The cameras recorded every stage of growth, from seed swelling to the appearance of true leaves. The experiment proved that plants can grow under lunar gravity, which is 6 times weaker than Earth's. The sprout survived for only a few days. When the lunar night fell, temperatures dropped to minus 170 degrees Celsius, and the plant died. But the experiment confirmed the fundamental possibility of growing food on the moon, a key requirement for long-term bases. However, the most important discoveries weren't biological, but geological. Using ground-penetrating radar, U-2 scanned up to 40 meters beneath the lunar surface, and what it revealed was astonishing. Beneath the moon's far side lies a network of giant underground cavities. Lava tubes formed billions of years ago when the moon was geologically active. When volcanoes erupted, lava flowed like rivers on the surface. The top layer would solidify into a crust, while lava continued flowing underneath, carving out tunnels. When volcanic activity ceased, the lava drained out, leaving behind hollow tunnels. On Earth, similar tubes exist in Hawaii and Iceland, but due to the moon's weak gravity, these can be absolutely massive. Some reach up to 1 kilometer in width and stretch for tens of kilometers in length. The largest discovered tube is nearly 2 kilometers wide and extends for over 50 kilometers, longer than the entire subway systems of New York or London combined. The ceiling height in some areas reaches 300 meters, the height of a 100-story skyscraper. Such a tube could easily host a city with a population of 1 million. And here's the most important part. These lava tubes are ready-made, naturally shielded shelters. Inside, the temperature is a constant 17 degrees Celsius. There's no radiation, no meteorite impacts, no extreme temperature fluctuations. These are ideal conditions for building lunar bases. 15 years ago, the Japanese Selene orbiter discovered more than 200 dark pits on the moon leading underground. Now it became clear these are entrances to the lava tubes, and the Chinese were the first to realize their value. The American LRO orbiter confirmed the existence of these caves using gravitational measurements. Where cavities exist, gravity is weaker. The map of anomalies precisely match the locations of the lava tube entrances. While NASA and private companies are debating how to protect astronauts from radiation with heavy shielding, China found a ready-made solution: natural bunkers formed by the moon itself. The walls of these tubes consist of basalt, 30 to 50 meters thick, enough to block cosmic radiation better than any man-made shield. Imagine an underground city the size of several city blocks, with stable temperatures and natural protection from all the dangers of space. In such conditions, one could create a sealed atmosphere, build living modules, laboratories, even farms for food production. Chinese engineers have already calculated how to seal off the lava tubes. It would be enough to seal the entrances with special airlocks, and inside it would be possible to maintain Earth-like pressure and air composition. Thanks to low gravity, the pressure exerted on the walls would be 6 times less than on Earth. But China didn't stop at just exploring. In 2020, Chang'e 5 delivered 2 kilograms of lunar soil to Earth, the first samples in 44 years. Analysis confirmed the moon's reserves of helium-3 are indeed massive. According to Chinese scientists, 1 million tons of this isotope would be enough to supply all of humanity with energy for 10,000 years. Chang'e 5 functioned as a miniature mining rig. It didn't just collect surface samples. It drilled up to 2 meters deep, analyzing soil layers of different ages. The samples turned out to be the youngest lunar rocks ever brought to Earth, only about 2 billion years old. Analysis showed that the concentration of helium-3 in lunar regolith is around 20 parts per billion. That may seem small, but in industrial-scale mining, 1 ton of lunar soil could yield about 20 grams of helium-3. And that amount is enough to power a 10-megawatt fusion reactor for an entire year. In 2024, Chang'e 6 became the first mission in history to return soil samples from the moon's far side. The analysis is still ongoing, but early data shows even higher concentrations of rare elements. The far side turned out to be a true treasure trove of valuable minerals. The Chang'e 6 samples contain material from deep within the moon, brought to the surface by massive asteroid impacts billions of years ago. Scientists discovered elements that are nearly non-existent on the surface: iridium, platinum, and rare earth metals, substances critical for modern electronics, which can cost several $1,000s per gram. And this is where the real reason becomes clear: why China is so focused on the moon and not Mars. Mars is a beautiful dream, but it takes over 9 months to get there. Communications have delays of tens of minutes, and emergency evacuation is impossible. But the moon is a cosmic outpost just 3 days from Earth, with resources that could change the entire global energy market. Estimates show that sending 1 kilogram of cargo to Mars costs 50 times more than to Moon. On top of that, Mars missions carry 10 times less useful payload due to needing return fuel. And flights to Mars are restricted by narrow launch windows that only open once every 26 months. The Moon is the complete opposite. You can fly there anytime. The trip takes just 3 days, and communication is nearly instantaneous. Equipment, people, and supplies can be delivered quickly. The moon could become a launch pad for deeper space missions, since launching from it is 20 times easier than from Earth. While Americans, Europeans, and Russians argue about budgets and dream of Mars, China is methodically executing a plan to turn the moon into its own space base. By 2030, China plans to land takenauts on the moon, not for a symbolic visit, but to begin construction of a permanent base. A new Super Heavy rocket Long March 10 is already in development, capable of delivering a manned spacecraft to the moon. This 90-meter-tall rocket will be able to launch up to 70 tons into low Earth orbit, similar to America's Saturn V. It will carry 25 tons to the moon, including a landing module and a crew of 3. Long March 10 will use eco-friendly fuel, kerosene and liquid oxygen. The first stage will be powered by 7 engines with 500 tons of thrust each. The second stage will have 2 200-ton engines. The third stage will use hydrogen and oxygen and can be restarted multiple times in space. Right now, technologies are being developed to enable 3D printing of structures using lunar soil. Chinese scientists have already learned how to make bricks from regolith that are stronger than concrete. A special robotic printer can construct a dome 10 meters in diameter in just 1 week using only lunar materials. Robots are also being tested for exploring lava tubes. One prototype is a spherical robot 50 centimeters in diameter that can roll over uneven surfaces and even jump up to 10 meters high. Inside are LiDAR system, cameras, and navigation tech for creating 3D cave maps. And what are China's competitors doing in the meantime? NASA promises to return to the moon by 2026 as part of the Artemis program, but the timeline has already been pushed back several times. Originally, the landing was planned for 2024, then moved to 2025, and now it's 2026. Problems persist with the new SLS rocket, the Orion spacecraft, and the lunar lander. The Artemis program has already cost American taxpayers $90 billion, but no astronauts have been sent to the moon yet. The SLS rocket has flown only twice, both times uncrewed. Each launch costs over $4 billion. Private companies like SpaceX are more focused on Mars. Elon Musk has openly stated that he's not interested in the moon, calling it a boring gray rock without an atmosphere. SpaceX is developing the Starship for Mars flights, although test flights so far have ended in explosions. Jeff Bezos' Blue Origin is planning lunar missions, but still struggles to consistently launch even suborbital flights. Virgin Galactic is focused on space tourism. Europeans and Japanese mostly play secondary roles in American projects, and Russia's space program has long since gone silent. This creates a paradox. While the rest of the world debates missions to Mars, China is quietly taking over the moon. And this isn't just about national pride. It's about enormous strategic advantage. The first to establish helium, 3 mining on the moon will gain access to an almost limitless source of clean energy. Imagine a country that can produce electricity 100 times cheaper than its competitors. Imagine industries powered by nearly free energy. That country would undoubtedly dominate the global economy. Whoever builds bases in lunar lava tubes will be able to use the moon as a spaceport for missions deeper into the solar system. From the moon's surface, it's possible to launch missions to asteroids, Mars, and Jupiter's moons. With gravity 6 times weaker than Earth's, fuel requirements are drastically reduced. Whoever controls lunar resources will dictate the rules in space. The moon doesn't just have helium-3. There's also water in polar craters, rare metals, and titanium for construction. All of this is crucial for future space programs. And while other countries waste time on endless debates and planning, China is already taking action. Every Chang'e mission is not just a scientific experiment, but reconnaissance of promising resource sites and a testbed for technologies intended for future lunar bases. Chinese engineers are already developing robots to explore lava tubes from the inside. One prototype, called Deadless, is a spherical device 50 centimeters in diameter, equipped with LiDAR, cameras, and autonomous navigation. It can roll along the ground, climb walls, and even jump in low gravity. They're also testing technologies for extracting water from lunar ice, because water can be split into oxygen for breathing and hydrogen for rocket fuel. Chinese scientists have developed a compact reactor capable of heating lunar soil to 600 degrees Celsius, extracting water vapor with 90% efficiency. They're studying the possibility of smelting metals directly from lunar ores. Experiments have shown that, in vacuum and low gravity, it's possible to produce ultra-pure alloys unattainable on Earth. These materials could be worth millions of dollars per kilogram. China is also creating special hopping robots to explore craters and lava tube entrances. In the moon's weak gravity, such robots can leap up to 100 meters, reaching areas inaccessible to regular rovers. One such robot, nicknamed the Space Grasshopper, weighs only 12 kilograms but can jump up to 1 kilometer. It's equipped with cameras, spectrometers, and a drill for collecting samples. In one day, it can explore an area the size of a small city. All of this means that within 10 years, China is likely to become the first country with a permanent lunar base, with its own sources of energy and resources, and the ability to launch missions further into space without depending on Earth. The rest of the world will watch as Chinese takenauts build cities inside lava tubes, extract helium-3, and launch expeditions to asteroids and planets using the moon as a refueling station. This is not science fiction. It's the logical continuation of what's happening right now. China isn't spreading itself thin across dozens of projects. It's focused on a single goal: to make the moon its own. According to Chinese plans, by 2035, there will be a major international lunar research station, but under Chinese leadership and following Chinese rules. Russia has been offered a limited role in it, but there is no place for Americans or their allies. The planned base will be located in one of the lava tubes near the moon's south pole. The area receives constant sunlight for energy, has water ice in nearby craters, and offers easy access to underground cavities. It's the ideal location for a lunar colony. The base will consist of several modules: residential, scientific, industrial, and energy. The residential module will house up to 20 people on a permanent basis. The scientific module will include labs for lunar and space research. The industrial module will process lunar resources. The energy module will use helium-3 fusion reactors. The most astonishing thing is, all this is unfolding before our very eyes, and yet most people don't even realize the scale of what's happening. While we continue to argue bitterly about whether Americans landed on the moon in 1969, the Chinese plan to live there in just a few years. China's lunar program is not just a space project. It's a geopolitical strategy of global significance. Beijing is investing tens of billions of dollars into its lunar missions not for science or prestige, but in preparation for a reshaping of the global order. In a few years, we may be buying lunar energy from China, watching their spacecraft shuttle between Earth and the moon, envying their space technologies that will have outpaced everyone else by decades. But the most alarming part is the international legal gray area. The 1967 Outer Space Treaty prohibits national ownership of celestial bodies, but says nothing about resource extraction. In 2015, the U.S. passed a law allowing private companies to own resources mined in space. China hasn't officially passed such a law, but in practice, they follow the principle: first come, first served. Imagine the situation. A Chinese lunar base begins mining helium-3 on an industrial scale. Americans and Europeans demand access, citing international law. China responds, "You're welcome. Build your own bases nearby." But by then, China will be decades ahead in technology. Space law experts are already warning of potential lunar wars, not in the literal sense. No one will be shooting on the moon, but economic and technological dominance by a single nation could lead to serious international conflicts. The Chinese, aware of this, are acting very strategically. They offer international cooperation under the umbrella of their lunar station, but on their terms. Russia has already agreed. Pakistan, Saudi Arabia, and possibly Iran are expected to join the project. This forms an alternative alliance of space powers under Chinese leadership. What about the traditional space leaders? The U.S. is trying to build a coalition through the Artemis Accords, but progress is slow. Japan, Canada, and the UK have signed on, but their actual contributions to lunar exploration are very limited. The European Space Agency is torn between participating in the American program and preserving its independence. Some European scientists are already working with their Chinese counterparts, bypassing U.S. sanctions. After the escalation of the conflict in Ukraine, Russia has been effectively excluded from Western space projects. Roscosmos is now increasingly aligning itself with China. This means China's lunar program gains direct access to Russia's experience in crew missions and heavy rocket engineering. But more importantly, China is already thinking several steps ahead. While others debate lunar bases, Chinese scientists are planning asteroid missions. From the moon, it's much easier to reach metal-rich asteroids. A single small asteroid could contain platinum worth trillions of dollars, instantly making China the richest country in the world with overwhelming dominance. China's space agency has already announced serious plans to send a mission to asteroid 2016 HO3 by 2030. This asteroid is especially interesting because it follows an orbit very close to Earth and contains a large amount of rare metals. From a lunar base, such a mission becomes routine. There's another aspect that is rarely discussed openly, the military one. While the Outer Space Treaty bans weapons of mass destruction in space, it says nothing about conventional weapons. A country that controls the moon gains massive strategic advantages. From the moon, you can observe the entire Earth in real time. A Chinese telescope on the far side of the moon is already detecting radio signals that Earth-based observatories can't pick up. In the future, a lunar base could track the movements of all ships, aircraft, and even vehicles on Earth. But the main advantage is control over technology. The first country to master helium-3 fusion energy will gain a decisive edge in all spheres. Cheap energy means cheap production, cheap logistics, and cheap computing. Imagine Chinese factories running on energy 100 times cheaper than oil or gas. They'll be able to manufacture any goods at prices no one else can match. This would overturn the entire global economy. Chinese supercomputers powered by lunar energy could surpass all other systems combined. China's artificial intelligence would gain a massive advantage in computational power. And today, AI is the key to dominance in every field. Chinese electric cars, airplanes, and ships powered by hydrogen from lunar water would be cheaper and more efficient than all competitors. China's space industry would be able to launch satellites and missions at a fraction of the current cost. And all of this is happening right now. The Chinese aren't waiting like others. They're taking action. Every year brings new achievements, new discoveries, new steps toward space dominance. In the coming months, the Chang'e 7 mission will launch to explore water ice at the moon's south pole. In 2026, Chang'e 8 will test base construction technologies. By 2028, the first cargo mission will deliver equipment for the future base. And in 2030, Chinese takenauts will make their historic lunar landing. But this won't be a repeat of Apollo, not just a few days on the surface and back home. This will mark the beginning of China's permanent presence on the moon. The first expedition will stay for a month in a lunar base. The second will stay for 3 months. By 2035, China plans to rotate crews every 6 months. By 2040, a permanent base for at least 100 people. The moon has once again become a stage for geopolitical rivalry. But unlike the space race of the 1960s, this time it's not about prestige. It's about real control over resources that could determine the future of all humanity. In the 1960s, the U.S. and USSR competed for the right to say, "We were first." Today, China and the U.S. compete for the right to say, "The moon is ours." And while the Americans debate budgets and push back deadlines, the Chinese are methodically turning this into reality. Perhaps in 20 years, school children will study these years as the moment when the fate of humanity in space was decided, the moment when one country placed the right bet on the closest celestial body, while others dreamed of distant worlds. History shows those who control key resources write the rules of the game. In the past, it was spices, then oil, then the internet. Tomorrow, it will be helium-3 from the moon. And all signs point to China being the first to access the source of limitless energy, while on the far side of the moon, hidden from our eyes, the fate of Earth's civilization may be decided.